Hey guys, today we're doing a a live stream with Steve Douglas. Alright, this is good. Hi Steve.
Hi Ollie, right. What we're gonna do today, the Bitcoin on Python.
Yep. Yeah, so yeah, we'll do some Python stuff and that's quite good with all the yeah.
I've got a script that we've prepared. That's it shows you how to speak to the full node using Python, and how to query the node and get some information from it using the RPC interface and the JSON format. And yeah,
JSON a module. It's a module, isn't it?
JSON is JavaScript object notation. It's a format for displaying and exchanging data. Most APIs speak with JSON format information. So it's a very ubiquitous way to exchange information between various computer programs, networks, etc.
Yeah, it's good.
So you can probably talk us through the code we've got here on the screen.
The code, the URL is the URL of, what is it, your date, your full node.
Well, yeah, start with what we've got at the top though. We've got the so we've got import requests. What does that allow us to do exactly? That allows us to request data from another server.
I don't know. I've never used requests. I've never used request actually.
Right, request is here. We're requesting information here, and I believe we're posting information. We're going to post the URL.
You're posting. Oh yeah, you're getting requests from the text file later on.
Well, no, this is going to speak to the Bitcoin full node on this IP address.
We've got a viewer. I think it's Neen.
So we've got the Bitcoin full node on this address. We've got the RPC username and password, and then the information we're going to send here. You can see we're going to use the URL here. We've got the authentication.
Yeah, the URL is one of the variables.
Yeah, and then we've got the authentication information there, and then the other part is the JSON data payload.
Yeah.
And payload.
Yeah, because
is here in our example.
I can see you put comments like Bitcoin Core by default listens on localhost 8343.
Yeah. So the Bitcoin.
You got URLs. Yeah.
The Bitcoin full node listens on port number 8332 for RPC requests. It uses port 8333 for Bitcoin blockchain data. If you want to speak to the node, you can speak to it on port 8332. And localhost is obviously where the node is running itself. Now this script is running on a different Raspberry Pi to the full node, and the full node's IP address is 192.168.1.40 on my LAN. And
you're doing it to listen to the to get data from the full node.
Yeah. And then we've got the username, Bitcoin RPC, and the password that we're using to connect to the full node. So then what we've got here is a bunch of code that shows the difficulty. Shows the variables that we're creating, and then we print those variables with some nice text on the screen. And you can see here we're passing to Bitcoin full node various requests. We're asking it what's the difficulty, what's the network information, can you get this information about the node, get the blockchain information, tell us how many connections we've got, and how many hash per seconds the network's currently operating at. So we're able to then run this code using here we go, Python.
Python.
You type Python and the name of the file .py.
I've actually never seen it run because I've never seen it run because I haven't got my IP address isn't the one that you have, so I can't run it.
No, well, you need a full node to run against, and
it's every got full node IP then 192.168.1.40 then.
Well, that's just the IP address I've given my node. You can give your node any IP address. It doesn't really matter.
Oh, you can choose what you want.
Yeah, absolutely. When you set your node up on your local network, because you want to port forward for port 8333 to exchange block information, it's best to allocate your node a fixed IP address, so that then when you allocate the port forwarding on your router, you don't have to change it if the node goes up and down. It just uses the same IP address all the time.
That's good. So explain to the viewers and stuff what Open Provenance is and Provenance.
We'll get to that a little bit later. let's go through this one first of all. So you can see we've got the connection count 8. I need to increase that. I've not got many connections at the moment. I'm not sure why. I've been fiddling around with a few settings.
So in the future, when you have loads of them connected to one.
Well, you would expect a connection count of I normally run at about 24 connections. You need 8.
Higher speed, is it? The speed, how much running on?
Well, it's how many other Bitcoin nodes you're connected to. So the more, the better. But
yeah.
the more you connect to, the more, yeah. At the moment, I'm only connected to 8. But the more you connect to, the better. But it does eat up more bandwidth the more you're connected to. So it's a trade-off between, you know, do I want to use my internet, or am I going to give all my internet to the Bitcoin network? But I found a connection count of around about 24 was sustainable and workable. You can then also see, it tells us, it reports back the actual Bitcoin difficulty, what the difficulty is. It's just over 113 billion, yeah. It's quite big. And then it gives us the network hash rate. So it's 0.95 exahash. Not long until it gets over an exahash now. And then we've got information from the blockchain. We can see here the blockchain. We're using an unproven
the blockchain in the full node.
Yeah, so we've got some information here from the full node about the state of the blockchain right now.
It took so much memory though.
395041, and you can see various statistics here about what soft forks are in place. So you can see soft forks regarding BIP34 and whether they're enforced or not here. And then there's other information as well. We've got some peer information here. We can see there's clients out there running Bitcoin XT that are connected to us. You can see their IP addresses and what block they're currently up to at the moment.
Another IP.
So yeah, well, with the Bitcoin full node, you have connections to other full nodes on the network. So you can see their IP, they can see your IP. You'd also see down here.
I'm going to talk quickly. Yeah. You can just keep talking, and you can say it to the people, got a couple of viewers.
Yeah. Well, I'm just explaining what you're seeing on the screen here. And you can see here, we've got a connection here from an onion address. So the Bitcoin full node is also running on Tor. And it doesn't discriminate. It accepts connections from both clear internet and the Tor web. So you can see it's quite a useful little script. You've got quite a few bits of information you're getting back from the node, and it's a very good introduction of how to speak to your Bitcoin full node using Python. And thanks to Ollie, we managed to get this working. So back over to you, Ollie. What have you got?
Yeah, I'm back. I'm back. All right. So, what was it? I went to the toilet. Sorry.
No worries. So yeah, we've run through the full node script there. It's giving us lots of information. You will see, however, it does take a little while to run. And the connection count's still 8. We've not increased that any at the moment. Hopefully it'll go up. You can see here there's people with nodes connected that have still not got all the blocks. You know, they're not far behind.
How many connections have you got? How many connections have you got to it?
For the node at the moment, 8 connections. Connection count, yeah, 8 at the moment.
You have.
Well, yeah, no, it generally runs a bit higher than that. I'm surprised it's only on 8 at the moment.
What are the connections though?
But there are other nodes connecting and syncing with the blockchain. So it's me downloading the new blocks from other nodes and me relaying blocks to nodes that are currently syncing their blockchain.
That's good.
So it's a continuous process. There's always blocks coming in and out, and the more connections you've got, the more in touch with the network you are.
It's good. Yeah, because then it faster it runs properly as well.
Maybe. So you need lots of connections when you want to send a transaction. You want your transaction to get propagated across the network as quickly as possible. So the more nodes you're connected to, the quicker you can propagate your transaction. The quicker you can propagate your transaction, the sooner you can get it in a block. Obviously, that depends on the fees. But it's something that is worth considering. You know, if you've got a full node and you're able to broadcast a transaction to many nodes quite quickly, that makes your transaction.
I'll probably get a full node soon.
Yeah, I recommend it. They're good, and it's a good thing to interact with Python, because there's just so much you can do with Python on there's so many different libraries and things you can download. You know, a lot of the hard work's already done. It's just what can we build?
Mm.
You know, there's lots of things we can build. You know, it's just going to take time.
Good. When I explain so when I'll be doing something in a minute with like Python stuff, it won't really do with the full node because I don't have the full node. I don't have a full node and stuff.
No, yeah, but that's not a problem. You can
Yeah, no, I can explain the code that I've written and stuff, you know, because of the thing, isn't it?
yeah, absolutely. Right. Well, I'll clear this screen and hand back over to you.
Yeah. Alright, so we're gonna do some stuff with the entire screen. Again? Alright, so that's my Bitcoin wallet. I'll talk about that more later. So what do you want to talk about? The encryption? Do you want to talk about the encryption program or the stuff that I've
Yeah,
created?
sure. Yeah, take us
For
through
the
your encryption program.
Alright, so this encryption program starts with importing OS, which stands for operating system,
Yeah,
and random, which is the I don't know what random is really. I haven't really used.
that's a
I don't
random number
really know
generator.
what it is.
It'll be a random number
Pardon?
generator. It'll be a random number generator.
Oh, then from crypto.cipher, this is actually actually I'll explain. I'll go to the web browser and I'll explain what it is. So it's crypto, a module for Python. I'm just gonna open it up because on what it is that so here you go to here python.packages. It's a module you have to install from online because you have to get it. So once you install it, you can install like a tar.jz file. Or if you have pip, like I told you about pip, didn't I?
Yeah.
Yeah, about pip, and then you can just install it from the PyCrypto API documentation, and then that's like the website it first came from, I think. And then no, that's not a joke, and that's not it. No, I'm not joking. I forgot. But if you keep going down on this page, it will say where it came from. Actually, it says here from http www.python.crypto.org.
Right.
See that? Do you see that?
Yep.
Is it lagging for you or not?
A little bit, but it's better than it was earlier.
Yeah, I saw it earlier. So now we're at download the latest release. Yeah, the latest release, and then you can install the tar.jz file. I think somewhere there might be like a pip sort of thing because I download it with pip.
So what exactly is in this crypto library? Show us at the top what we've got, what we get.
Alright, so with it, I'll explain. I'll actually go to the actual file that I got, the actual file when you install it. So I'm not going to install it because I've already got it. But let's go to, I'm going to go to my Acer, which is a C drive, and I'm going to go down to Python 27, which is it. And then what you have to do, if you install something, when you go to control panel and you go to environment set variables.
Yep. Yeah, in that path we were doing.
So if I'm gonna go there now, because I'll link that to what I do. I link that to my Python thing in the variables into my Python. I'll just show you quickly. So path, and this is my Python site packages. So whatever I install online goes straight there once I extract it from the command prompt.
Yep, I'm with you.
Yeah, and then I can just push OK and OK, then close that. So when I'm here, I go to lib, and I go down, and I go down to the where should I go to? Here we go. Site packages. Is it lagging for you or not?
Yeah. Yeah, it's slowed right down.
I'll just wait for you at the site packages page.
Right, I've got.
So
Oh, yep.
So I'm going down to PyCrypto. I've got PyCrypto somewhere. It's a long time ago, and here we go, crypto. So it's not called PyCrypto. We see crypto there at the bottom.
Yeah. Yep.
So I'm going to click on that, and I'm going to go to ciphers. There's loads of things you get with it. I'm not going to go through all of them because it will take a while.
Oh, I see.
Go
So
to
you get all
ciphers.
different cryptographic functions in ready-made libraries.
The algorithm. Yeah, you get the algorithm encryption. You get the AES, which is quite cool. Sorry, I just did something else. I need to close that. So yeah, I got the AES. You get a bunch of other things which I haven't really used. You get block algo.
Oh yeah.
And you get blowfish, which is another. These are just different ciphers that you use. There's AES and stuff. I think they're like, I don't know, they're algorithms, aren't they? I think ciphers.
Yeah, yeah, yeah. Yeah,
We go to
different ones,
hash, which
different
different hashes
encryptions.
like the SHA-256, the SHA-256, the MD5s and stuff.
Yeah, so
Secure hash algorithm.
you've also got the RIPE MD 160 there, which is another one, the Bitcoin one.
I got MD5, which is MD5.
Been depreciated. I wouldn't use that anymore if I were you.
No, MD5 is an old thing.
Yeah.
Yeah,
Yes.
the SHA-256 is good.
Yeah, there's too many rainbow tables for MD5 stuff, so don't use that.
Yeah, it's true actually. I've watched things on that. There's the secure hash algorithm. There's 512, there's 384, 205, 56. A lot. It's a lot of things on it. So let's go. Look at all these. So alright, so you get a lot more than that. You can get protocols. You get public key. I remember public key. A public key is when you have a Bitcoin address, isn't it? And there's a public key and there's a private key.
Well, no, a Bitcoin address is a hash of a public key, but yeah, these public key algorithm things are like what they used in PGP. You know, RSA, DSA. These are public key cryptographic algorithms.
But the public key you can give to anyone if they want to send bitcoins to you. But the private key you have to keep secret.
Yeah, you keep your private key secret, but with Bitcoin, you don't give people your public key. You give them your address, and then it's even more secure than giving them your public key.
Isn't the public key, is it bad?
Well, you know, the more information you reveal, the less secure you are. So you're best off to reveal as least information as possible. So your Bitcoin address is less information than your public key.
Yeah, I mean public key you don't have everything.
No. They couldn't spend your bitcoins with your public key.
Private, I said.
Oh, your private one, yeah. That's it. Game over.
That'd be quite fun.
You don't want to do that.
Alright. No, I wouldn't do that. I know about that. When I first wanted to start doing mining Bitcoin and stuff. I watched a video on it, and it said never give out your private key. Public key you can, but it would be bad as well because it wouldn't be as secure.
Absolutely. Absolutely.
Yeah, so I'm gonna go back. I'm gonna go back to the encryption thing now.
Okay, brilliant.
So are you at the encryption ideal thingy or not? Where you are?
Yep, I can see where you're in the base. You're in the Bitcoin folder, right? Yeah, back to that. So we've imported the two AES cipher and the SHA-256.
Yes, and from crypto.cipher, because that's actually hash a SHA-256, a secure hash algorithm. It would I think it only can encrypt, but it wouldn't be able to decrypt. That's why I had to import.
Yeah, SHA's a one-way algorithm.
Yeah. So then I define a function called encryption. Encrypt.
Right.
And then I have a variable key and file name, don't I?
Yep.
And then chunk size equals 64. 'Cause 64 is the SHA-256 size, isn't it?
I'm not sure.
Of the algorithm, I think. The key. I'm not sure about 1, 2. I don't know about 1024. But output file and then the encrypted plus file name. File name is actually something later on when I want to import stuff, and when I run this program, it will explain like it will say like what do you want to encrypt or decrypt, and then you have the file name, and that's what the file name is.
Yep, I'm with you.
And then file file size equals, and then you want to str is a string. Remember?
Yep.
String. But you were doing it in the Open Provenance thing, weren't you?
Yeah, we're going to use some strings in that. Definitely.
Yeah, because I remember, because you sent me some stuff about that. Then OS, you remember OS? I remember we used an OS system to clear the screen.
Yep, operating system. So we're going to use the operating system path, get size to work out the size of the file that you just.
Yeah, I'll actually do an example here. This won't actually be in the code I'll delete after, but you go os.system, and then you would go like that in you do that, wouldn't you, in Windows?
Yep.
In Linux and Mac is that.
Yep.
Yeah, so I'm just going to clear that now, but I'm just saying what it meant. So then you go os.py.get size, get the size of the file name, which is actually 16, which will be I'll get on later on for the range, and then dot z. I don't know what z file. Let me have a look what it is. It will say here. If it's there. Oh no, it won't. It normally does actually when you go. I don't know. Have you used Z file before?
No, not use that. No, I imagine it's some
I
kind
don't
of
know what
padding.
IV. Some of this thing, some of this thing is just a bit complicated. It's a bit weird because I created this ages ago.
So there's an IV. You've just created a blank variable there, so you initialize your variable,
Yeah.
which is a good thing to do, because if you don't initialize your variable as nothing, it could be anything. It's always best to initialize it as a nothing. And then
But I do something later on with that. For iron range, which is range 16 range. I think it's the range of the function, maybe the range of the variable.
well, it's just a number 16.
Then,
So for 16, well, what's I for I? Where's I? Where do we get I from?
I can equal anything.
I
can equal
0,
anything.
isn't it, to begin with? Yeah, so that's, I don't know, 17 iterations, isn't it? 0 to 16.
So IV plus equals CHR, then the random dot ran it, which would you? That's what random is, and it.
Yeah, random integer, and what you're doing with your plus equals, you'll keep appending information. So you're building up the IV variable to be a load of random characters. That's to give you some entropy.
And after that, like the AES part, the encryptor equals AES.new, which would be that's the sort of thing that I was doing for encryption. You use AES, don't you?
Yeah, so you're using the AES algorithm. You're declaring a new algorithm using the key, the mode.
And you use SHA-256 later on for the encryption and stuff.
So I'm not sure. Oh, the key. Yeah, the key's the user supplied key, isn't it? That's the input that you're going to get later. So
then you just put a lot of things in there, and then you just put with open file name and then RB. What's RB? A Ruby file or something?
I'm not sure. Read.
No, I don't know.
Read binary.
Huh?
Read binary.
Read binary, yeah, read binary, because read binary is because it's kind of encrypted, isn't it? It's going to be encrypted.
Well, you're reading any file, aren't you? Don't care what the file is.
Yeah.
So you're just going to read it in a binary format.
Binary is what the computer understands until until you write other code. Or...
Well, yeah, and we're not assuming it's going to be a text file. It could be a graphic file, or
Yeah,
be a
then
Word document.
With open output file / read write binary.
Yep.
And then as out file, because the in file and then the out file.
Yeah, so you bring it in, encrypt it, and then put it out.
Yeah.
So you'll see a little bit further.
File, yeah.
So what you've done is you're writing at first the header of the file, and then you write out the data of the file.
Yeah, then out file dot write, and then the file size, which is up here, file size dot this bit here. If you're there.
No, I've lost you. I've got your profile come up. Hang on. Right, I'm back with you there.
Oh, it's there. Next thing will be outfile.write and then IV.
So you're writing out that chunk of data that we had earlier.
Then while true chunk equals infile. So, it's gonna take a long time for me to say everything. Basically, I'll just run it quickly. It'd be a good idea, isn't it?
Yeah.
I'll explain more down here because this bit's more like the important parts after encryption decrypted. You go define a key, get key, and the hash it equals to SHA-256.new password, but the password is a variable that I've stored in get key.
Yeah. And that's user
returning
supplied, isn't it?
A digest is actually a really cool thing for like a mumbling up something, isn't it, in a way?
Well, no, a hash is also known as a digest.
Yeah.
So it's a fingerprint.
It's a hash.
Right? So it's a one-way fingerprint.
Yeah, fingerprinting. You were talking about that earlier, actually, before we started live stream, remember?
That's a good way of referring. Like people perhaps understand it a bit more when you say a fingerprint. It's like something they can relate to.
Then there's the most common. The next thing, the most common defined function name is main.
Yep. Oh, and then we got.
This could equal to anything. Choice equals to raw underscore input. If you were using Linux, I mean, if you're using the Windows 3.4, no, Python 3.4 version, you would have to go input rather than raw underscore input.
Okay.
I think I told you that because I told you you don't remember yesterday you got an error when I sent you.
Yeah, but when I was trying to input a dot character, it wouldn't allow me to input a dot. Using input, it had to be raw
underscore input. You're using 2.7, aren't you, in your Linux stuff?
Yeah, I believe so.
Then next thing is, would you like to encrypt or decrypt a file? Which would be encrypt. Would be you have this thing. The reason I've got the little things around the brackets around it is because you need to actually highlight #E to do it in D. The next thing is if E. Remember if choice, if else statements now, aren't we?
Yep.
If choice, which is the variable name of this, if choice equals E.
Yep.
Yeah, there. If choice equals E, then file name equals then file name equals raw encrypt. So that means after they push E, then the file to encrypt would be the file you want to name. Then password equals raw underscore input password, which is the password. I should have another thing in here actually saying what the password should equal to. I should have that.
Well, no, the password.
I'm not sure how
No, the user has to supply the password, don't they?
Yeah, I know, but I should have like a password when it does it, it saves it, and you can't use any other password.
But then it becomes insecure. No, that becomes insecure because the password's in the head of the user. If you write the password with the file, then the encryption is useless because it's insecure. Anyone can access the file; they can then decrypt it because the password's within it. So you don't want to keep the password.
So I just have to keep the password like that.
You don't keep the password. You just can't.
So I get rid of the password then? Yeah.
No, you need to grab a password from the user, but you don't want to store the password with the encrypted file.
Oh, right.
That would be bad OPSEC. You just
OPSEC.
Operational security.
Why is everyone talking about that?
Well, you have to be careful. There's hackers online, so you don't want to
hackers. I thought meant OPSEC. Yeah,
leak any data. So yeah, it would be poor operational security to store your passwords with your encrypted information. You just want to keep the two separate.
Then encrypt, and then the get key and the password and the file name, which is actually getting the whole thing of get key, which is the key up here, and then you're getting
which is the hash of the password. Well, the reason you do
then
that as well.
Done, and you've done it.
Also,
then else if, which is edit.
Yep.
Pardon?
I was going to say, but what you do with the password is you hash it to create so that even if you should store the hash of the password, you're using the hash of the password, not the password itself. So it's just another security step.
Yeah. Then else if, choice if it equals means decrypt D, and then file to decrypt and a password, and then exactly the same again. And then the bottom, the if name, and the old version you used to have to do that anyway. And then let's just run it. And it doesn't work. No, I'm joking. No, it's because I'd done something else. Me wanted to kill it and run it again. Alright, so here we go. So we're gonna go. Actually, I need to create a little file quickly, don't I? So let's just go that. Then let's go ha.txt. Then you can store the value. You can just make the value. You can make the password anything, can't you? So I'm just gonna call it Ollie.
Can you make it so that when the user enters, they don't see the password?
Yeah. Then the next thing, we can just go back to my desktop. I thought I've encrypted a file. The file actually before I can say it. I can call this one here. I called it hello hash.txt, and then I can go to basic Python. No, not Python. Bitcoin. I don't know. I call it Bitcoin. It's called that. Then you see here encrypted how.txt. See it there?
Oh yeah, yeah.
So now I open that up in edit, and here you go. It's encrypted.
I'm still lagging. I'm waiting for your screen to catch up. Oh yeah, that's it. Absolute nonsense.
Yeah.
Gobbledygook. Yep, brilliant.
Yeah, it's good then.
That works well.
Yeah, yeah. Anyone can actually take that code and do what they want. I put it on the Slack saying anyone. I put the code on Slack anyway, which is good.
Yeah, it's quite useful.
And the decrypting part now. Let's do the decrypt of it. Let's decrypt that part now. Let's go hierarchy. Part to decrypt. It'll be called encrypted. Now, if we go
But
back
the password
to this
wasn't
file
P.
here, I can call it anything I want.
You should need the same password to decrypt as what you encrypted with.
You don't have to, do you?
Well, yeah, otherwise it's not really encrypted because it's just decryptable by anyone with any word.
It's what's meant to happen anyway, because, you know.
So what happens if you look at that file now, the decrypted version?
Right, let's go down. Should do that again. Alright, so let's go back to that encrypted file, reload, and then I'm just gonna get rid of that. Now let's go back to the encrypted version. Alright, so I need to reopen it. I'm not sure if I'll have to open the other file or open that one. Have a look.
But you need to look at your program to see where it outputs. Does it rename the decrypted file, or does it give it its original file name? So
I think it's the original file name.
if you look at it,
It's what I did once. I encrypted the actual encrypted program. How small the encrypted is compared to how big the program is. Funny, because I can actually run
it's
this
very
and
good
it would
at
actually still run.
encryption. Is good at compression as well. So go back to your editor there, and no, not that one. Where's the file that we were using, the encryption one?
Oh, yeah, it is the encrypted one. Let me open it in.
No, the program.
Oh, okay.
Show us your program, because we don't know.
The encrypted version. The encrypted version or the normal version?
Oh, you're back. Sorry, no. Show us the program, the software that you're writing, the script that does the encrypting and decrypting. Just waiting for your screen to catch up. Yeah. So where's the out file? So it writes out the file name. Doesn't put encrypted file name, does it? Output file is just output file. So yeah, it's back to the original file name.
Yeah.
So you've got the encrypted. Have you still got the? You've still got the encrypted har.txt, haven't you? So decrypt that again, and you should end up decrypt it. Yeah, decrypt the ha.txt file again, and you then the encrypted one. You'll end up with a decrypted version again.
I'm stupid throughout this whole live stream. I actually no one could view anything I'm doing because I had it on yours by accident. I need to switch my computer on charge actually.
Right.
I'll just plug my computer in quickly.
Cool.
You alright?
Yep.
Alright, so now, what is that? Decrypt the other thing and encrypt the other thing.
So if you delete the original file, see that's another thing when you want to consider when encrypted information, it's sometimes good to erase the clear text.
What? The clear text?
Yeah, the unencrypted information.
What do you mean? Delete the other bit.
Yeah.
Oh yeah, delete the original. That's what I meant to do. I forgot. I remember now. I remember you meant to delete.
So in your
encrypt
function, in your encrypt function, you want to remove the original file from the disk.
Yeah, I remember now. I remember because I ran this program in ages. You skiing today?
No, not today. Just
cold.
At work. No, it wasn't too cold actually. It was a good day, but I had a few other things to do.
Did some programming stuff.
Yeah, and some paperwork and.
Paperwork? What do you write then?
Well, I work for myself, so I have accounts and things to do. Many things to do.
Oh, you do the website, don't you?
Customer liaison, yeah. Programming, technical support, all of it.
don't think how do you get paid for like working for yourself and stuff with
It
what you're doing?
varies. It varies.
What do you pay yourself?
Yeah, it varies. Depends on how well I'm earning. If I'm doing well, I'll pay myself some more. If not, I won't.
So see this, yes, I'm just gonna call the password A, and then okay, now I can open the file. I'm not sure if I'd actually deleted the file in the first place, but okay, here we got encrypted hard.txts here.
Yep.
So I'm gonna open it up, edit with that. So you see it's encrypted now.
Yep.
So now I'm
Yeah,
gonna
I'm
delete
still
the
a bit
original
lagging,
file.
but it's coming.
Delete the original file. I'll delete the original.
Right.
Now go back to this. Run this. Let's go Decrypt. I'll be. Let me get the file name in. Encrypted. .txt. And the password's A, isn't it? A. I need to delete that. So now I'm not sure if I'll have a new folder or I'll just have another one like it. So we've got it back now, haven't we? We've got path.txt back now.
And it should.
So now we open it. It should print back Ollie. Hello, I meant.
Hello,
There we go.
yeah. So try decrypting it with a different password. It shouldn't work. Run the program again.
I'll delete
No,
the original then.
leave that there. That's fine. Leave it there. Notepad++ will detect a change in the file.
What do I just run it and
run
then
this?
push decrypt.
Yep.
And then encrypted.
It's a decrypt, and then put in the encrypted text.
File's called encrypted.
Yep. And then different password.
Let's call it Ollie then. The password.
Yeah.
Done.
Now go back to Notepad, and Notepad should have detected a change in the file, and you can see it's there. It's not decrypted. It's not.
Is it more then?
But it's not. It can't decrypt it because the password was wrong. That's what you want to happen.
That's clever then.
That's the desired effect.
Yeah, I didn't really understand about that.
Well, yeah, you don't want anyone to be able to get the encrypted information back. That's the whole point of encrypting, is so that only the person with the key to decrypt it can then view it again.
It's good though.
Yeah, it works very well.
People have been saying it's basic stuff. No.
Yeah. Yeah, we've got to start at the beginning. Well, it's been great hanging out with you, Ollie, but I'm going to have to call it a day for now. It's, hopefully we'll get back online again soon.
Again, maybe with Chris next time.
Yeah, hopefully he's get some good news today and he can get well soon and we can see him on here soon.
That'd be good.
Great, well, thanks for your time, Ollie, and I'll speak to you soon. Cheers. Take care. Bye-bye.
See ya.